h of x equal x plus 2 has power 2 minus 2. So with power 2 function is a quadratic function. So the basic function of the quadratic function is a U shape, it's a parabola facing up. So this is x power 2 function, the parent function of the x power 2 function. Now the h function has plus 2 is inside of the parentheses. So this indicates the graph will shift to the left 2 units and then go down 2 units because minus 2 is outside of the parentheses. So the way we translate this function by using the parent function, we just simply to shift the vertex point to left hand side 2 and then go down 2 units here. So this will be the new vertex point and the graph will remain the same shape, facing up shape from the parent function itself. So the blue color graph here is your h of x, which is x plus 2, everything squared minus 2. The next one is a reflection about the x-axis and the y-axis. If the function f is a parent function, then when y equals negative f of x, the negative sign is outside of the function. It's identical to the graph of y equals f of x, except that it is reflected about the x-axis, which means you deal with the upside down, facing up or facing down. Along reflects across the x-axis, or the negative sign is outside of the function. That means you deal with the reflection about the x-axis, which means upside down. When the negative sign is inside of the parentheses, that means you deal with the graph reflection about the y-axis. That means it's go left, it's left or right. So outside negative sign is upside down. Inside negative sign is go left or go right along the y-axis. So we take a look example. G of x has negative sign outside, so I know this is reflect about the x-axis. So this is upside down. So minus sign it will reflect about the x-axis, right? So we need to look at x plus 1, which means this would be the mirror image from the x plus 1. So when we graph the x plus 1, you have plus 1 is inside, I mean it go left 1 unit. So this would be the x plus 1 with absolute value. So the g function just upside down about the x-axis based on this function. So your negative x plus 1 with absolute value, right, just upside down. So this would be just negative x plus 1. So recognize the basic function you have here, and then the negative sign you just reflect upside down from the plane function. We try this one. H of x has negative x plus 1 with absolute value. So this negative sign indicate we have to reflect the graph about the y-axis. So this function is a reflection of your x plus 1. So I'm going to sketch x plus 1, the graph of x plus 1 and do the reflection about the y-axis from x plus 1. So x plus 1, that means we need to shift to the left 1 unit, right? So let me do it here. So this is x plus 1. Now, h of x, we have to reflect along the y-axis because this negative sign. So I'm going to change this color. Based on the y-axis, it reflects, which means there's a mirror image along the y-axis. So this point is -1. The mirror image on the other side from the y-axis must be a +1. So the vertex point, it will reflect on the other side with the vertex point has 1. So this one, the green color graph, would be -x plus 1 with absolute value. So you need to consider the mirror image. Depends on which direction the function reflects. When the negative sign is outside, you deal with the upside down. So you just sketch the graph of without the negative sign. So sketch that graph first, and then you rotate upside down. When the negative sign is inside, you deal with the left and right reflection. So you need to consider your mirror is in the center on the y-axis here. So when you reflect along the y-axis, you need to consider the other side, the opposite point on the other side. I hope that makes sense to you. Vertical stretching and shrinking to the graph function. If f is a function and k is bigger than 1, it's a positive number. Then the graph of the y equal k is multiplied to the outside of the f of x, outside of the function. And keep in mind k is a positive number. And it's bigger than 1. And keep in mind k is bigger than 1. It can be obtained by stretching the graph of y equal f of x vertically by multiplying each value of f of x by k. In other words, when you have the function has a number multiplied to the outside of the function, and that number is greater than 1, you deal with a vertical stretching. Vertical stretching. When you have the vertical stretching, that means your graph will go skinnier. It will near to the y-axis. That's a way, it's an easier way you can identify it. So it will tend to go skinnier of the graph, and the graph is near to the y-axis. If you look at the graph here, the red color line is a parent function f of x. The blue color is the translated function. It has a k multiplied with the f of x. And keep in mind, your k must be greater than 1. If k is less than 1, then that will be another case. When k is between 1 and 0, so this number is less than 1 and greater than 0. But it is a positive number, keep in mind. So when you have k is between 1 and 0, the graph, you will have the vertical shrinking. So vertical shrinking. That means it will go flat, go flatter, is near to the x-axis. So vertical stretching near to the y-axis. Vertical shrinking, it will go near to the x-axis. And the graph will go flatter. If you look at a blue color line here, because the k is between 1 and 0, so it go flatter. It's near to the x-axis. So we take a look at example. G of x has 2 multiplied to the absolute value function. So I know the absolute value function is a V shape passing through 0, 0. So this is x with absolute value. Multiply 2 to the absolute value function. This is 2 is bigger than 1. So I know without creating the table, I will know the graph, it will go skinnier. Go skinnier and near to the y-axis. So this would be the 2 multiply x with absolute value. If you cannot visualize it, like the way I show you the work here, you can go with the table. So create a table x and the 2 multiply with absolute value x. Because this is a y, right? This is a y equal. Which means this is your g of x. So you can create an x value with 0, 1, 2, -1, -2, use a 5 point, and then multiply 2 with your absolute value function. That means you have 4, 2, 0, 2, 4. And you can sketch the graph by using the point here to plot it. So you have -1, 1, 2, 2, 1, 2, 1, 2. So you have 0, 0, 1, 2, -1, 2, 2, 4, -2, 4. So your graph, it will go skinnier, near to the y-axis. But this section we are learning the translation. So normally I show the word like this way by using the understanding of the translation to move your graph. G of x has half multiplied to the outside of the function. So this number indicates it's a vertical shrinking. So that means the graph will go flatter near to the x-axis. So the basic function of the absolute value is the green color line. Now I'm going to sketch the graph of the half multiplied with absolute value here. It will go flatter and near to the x-axis. So the purple color line would be your half multiplied with x with absolute value.